Today we're going to talk about Go, if you did not know that already. Um, and first thing I'm not going to do is I'm not going to try to sell Go to you. I'm not going to tell you it's the perfect language, it's the best language there is. I'm going to talk more about, in general, what it is, what are its concepts, what is the motivation behind it, what are its uses, and what are its flaws. So let's start. Well, many of you already know about Go, have heard something about it, have heard how popular it is, or read some critiques about it online. So, why is it so popular if it's such a young language? There are many people who are trying to answer that question, and the first obvious answer is maybe that because it comes from Google, and Google is trying to push it, promote it, but that's not really the right answer. I think it's more because Go is actually achieving some of its goals and stuff that really wants to contribute to the development community. And if it's so good, why are so many people criticizing it? And obvious answer is because it's popular to criticize on something that is cool and it's new. And the right answer is also that Go has its flaws, and it's not perfect, and it's a bit controversial on some topics. It tries to reinvent the wheel in some cases. Goes back from what the people have been used to for so many years, and maybe people don't like it because of that. We'll go more in depth about that a bit later on. Some history. Go was not developed by Google, it was developed at Google. So it's not a Google product like Google Docs is or Chrome. It was actually like a homemade project from Google's three developers, Rob Pike, Ken Thompson, and Robert Griesmer. If one of those names sounds very familiar, you're right. Ken Thompson is the original author of Unix, and he was great friends with Dennis Ritchie, who was the author of C. So no wonder Go borrows a lot and looks up to C in so many ways. So like I said, it was not developed by Google, it was developed at Google. And they felt the need to develop a new programming language because they felt a lot of frustration with using traditional system languages there at Google. So they were like, we need something better. And that's why they initially developed Go in 2007. And it kind of caught up with a lot of their colleagues and their friends, and they decided to release it public in 2009. And that was the first initial release of Go. How were they motivated to create new language when we have so many languages out there and so many technologies that have been developed for the last 20, 30 years? What is the motivation to create something brand new and something that is not based off anything that is out there? So first motivation is that for the last 20 years, computers have become exponentially faster, but development, and software development in particular, did not get any improvements off of that. So the gap between hardware and software development productivity is increasing. They felt very frustrated with cumbersome type systems and slow compilers in system languages they were using, with weak support for garbage collection and weak support for concurrency, because we have all this 64-bit processor everywhere, octa-core, quad-core processors, and no language which can really reflect and benefit from this increase in technology. Most popular languages that everybody uses are old at least 20 years or even more, which they were not designed for the current state of technology that we have right now. So they kind of identified three major points or three virtues that each language strives to, which is efficient compilation, efficient execution, and ease of programming use. So that means that language should be able to compile fast, to run fast, and for me as a developer to code fast with it. None of the current languages out there in the market fulfills all three of those points. Many of those fulfill only one or maybe two, but no one fulfills all three, and Go is the first to attempt to cover all three aspects of it. It's not perfect. Go is not the most fastest compile language, it's not the most fastest at execution, and it's not the most productive, but it kind of bridges the gap a lot. So it is fast for compilation, it is fast for execution, and it is fast for development. Some core concepts which define Go is that Go is strongly typed, it is static, and it's compiled language. Current trend or hype is probably that in order to have a productive language, the language needs to be dynamic. So like we, for example, eliminate the compilation part of it and we only do with interpretation, which is not very effective. And people who created Go were like, static checking, the compile time type checking is very beneficial. We don't want to throw that away. So we want to have a language which is really strongly typed, which is compiled, and which is also not backed by a virtual machine. Really, there is no virtual machine in Go. It compiles natively on all platforms and all architectures. Many people complain about that. They were like, but why not a VM? Because VMs have been there to leverage the differences in platforms to provide us the ability to execute code on all platforms without us having to worry about that. And there have been like a lot of improvements on virtual machines for the last gazillion years. I don't know. But when you think about it, do you really need a VM now that you have 64-bit processor in your pocket and 64-bit processor in your laptop and 64-bit processor in your Raspberry Pi? You don't really need a VM, you just need a better compiler. So it's one of the Go's strongest selling point that it's just natively compiles on all platforms, even ARM on mobiles as well. It is also because of that reason that Go is designed for concurrency. Like there is no very efficient language that is easy to use and can benefit from the multi-core processors. Go doesn't have a dominant paradigm, meaning Go is both object-oriented and functional, and at the same time, it's neither object-oriented or functional. Meaning, it features some object-oriented features, but not as other full-blown object-oriented languages, and it does feature some functional features, but we cannot call it fully functional languages because Go lacks generics. We'll talk about that a little bit later on. Go strives to be very simple. That is because for language to have a huge user base and huge adoption, it needs to be simple. It needs to be easy for a developer to get into it and to make productive stuff with it. So Go's language specification is so slim, it's around 60 or 70 pages. So maybe it was smarter for all of you to read that language spec back home instead of coming here. So it's very easy to get into, both if you're like junior level developer or if you're a senior. It's very easy to grasp its concepts. I mean, of course, it's easier if you have more experience because Go kind of borrows from everything out there. And because of that, Go had to strip down some common language features seen in other languages which kind of resulted in some hating over the internet and some blog posts. But Go tries to leverage the, like I said before, compilation times, execution times, and developer productivity. So they don't want to like throw one of those trees away, only to have all the language features that all the other languages have. So like they don't want to build a language that will be liked by developers. They want to build language that is used efficiently by developers, which means development productivity. Go is going with C-like syntax. Why? Because most of the languages do. And if you want to have better adoption, you do not invent a new syntax. You just go with what's been out there for 40 years already. We already said, it compiles fast, because nothing spells productivity like not waiting to compile. And also features garbage collector, because nothing spells productivity like not having to manually manage all the memory. It features some dynamic typing, kind of some features borrowed from dynamic languages, which is just to reduce the code base in some cases. It has a very rich standard library, not very close to Python's, but still, like, you know how in your usual daily work, whatever you want to do, you always have to look for some library. You always have to look for some framework that will do stuff for you. And Go has a lot of stuff built in. It has a web framework, it has a testing framework, it has HTML rendering engine, it has JSON and XML encoders, it has crypto algorithms, and etc. I mean, really a lot of stuff which will allow you to, whatever you want to do for your modern day needs, you can do it with the standard library. You don't need anything else. You also have the Go tool, which is a command line tool which, besides allowing you to build and run your Go programs, it can also fetch you dependencies, it can print you documentation, it can format your code to Go standards, it can also analyze your code for bad constructs or styling principles, I don't know. And it's also very easy to extend on that tool, because there are a lot of community provided tools which also help with the development productivity, like third-party debuggers, third-party dependency managers, and so on. Okay, let's talk about some prominent language features and how they differ from what is differ, or how are they similar to what the average developer is used to. So we already mentioned the familiar syntax. When you look at this, like, your average developer will kind of have a clue what's going on, because you have like standard package declaration, you have some imports, you have some type declaration, there's some function or method, whatever you think it is. You have a main function, which will usually, just run your main program. You initialize the city and you invoke a function over it, and then you print the results. We can run this example, and it says hello Belgrade. Very, very easy to read and very familiar. Looks like a lot of other languages. So if you're doing like C, C++, Java, C#, JavaScript, you would fit right in. We already mentioned that Go is functional and not functional at the same time. How is it functional? It's functional because functions in Go are first-class citizens, meaning functions can be assigned to variables, they can be passed as arguments, they can be returned as values from other functions, which can result that you have the ability to do function composition like you would do, for example, in JavaScript with callbacks and everything. You can still do the same thing in Go. We can see this from example. that we have function g declared, which takes function f as an argument and invokes the function f inside the function g. In our main function, we are invoking f directly, and we are passing f to the function g. And when we run it, you see, so you can go all overboard with function composition here, but it's not very effective. And there has been a great talk at .go at Paris last year about functional Go. If you're interested more, take a look at that. But why is Go not functional at the same time? Because it doesn't support generics, so it would be very hard for us to implement common functional methods. I mean, common functions used in functional programming like map, filter, and reduce. We would have to implement those methods for each and every type we're going to use them on, and that's not really efficient. Same with functional paradigm. Go is also object-oriented and not object-oriented. It's object-oriented because it allows you to code in an object-oriented fashion, meaning you can declare objects, you can have methods on them, you can invoke them, but it's not object-oriented because Go doesn't support type hierarchy, meaning not that it doesn't support it, it doesn't have any type hierarchy, meaning you cannot extend something in what would be in your like usual languages, or one object cannot extend another. You can only go with composition. In this example, oh yeah, one other big difference is like when you're declaring an object in some other language, you usually have classes for that. And in classes, you would define attributes, you would define methods which that object has. In Go, it doesn't work like that. In Go, you define a type, which is a struct. Whoever used C before know what a struct is. It's an object-like structure. So you only declare properties in it and nothing else. If you want to have methods, you have to attach them externally. Like in this example, we declared the person object or struct, whatever you want to call it, which has some properties. And if we want to have the hello method in it, we have to attach it externally. So this function hello is attached to the method receiver, which is a person. And when we run this example, Para will say hi. If there are any Paras here, I apologize for using you as an example. Yeah, because Go doesn't support type hierarchy, it explicitly prefers composition over inheritance. Meaning, like I said, you cannot extend something, you cannot build huge type hierarchies, you cannot make your types, your objects more generic. You have to be a little bit more verbose about it. And this is why some people are complaining that Go is very opinionated. That's because it enforces you one type of opinion on the developer, because composition over inheritance is a huge topic in development circles, and Go just tells you have to go with composition. There's no inheritance. Although there is a way to mimic inheritance instead of composition, but this is a topic for some other time, for some workshop probably. So if we don't have this complete super type system with generics and with no type inheritance, what do we have? We have interfaces, which is just a collection of functions. So any type can be an interface as long as it has those functions attached to itself. It's very similar to interfaces in, for example, Java, where when you implement an interface, you would also implement all the functions that that interface is providing or requiring. let's take a look at this example. We have the thing interface with the hello function, which returns a string, and we have greeting function, which takes a thing and prints out the results of its hello method. We see that in our main function we are declaring person and an animal and passing it on through the greeting function, and it would print greetings from Finn and greetings from Jake the dog. But how did they implement the interfaces? Very simple. There is no explicit implementation like in other languages. So we never stated that the person is implementing the thing interface. Only thing it did is have the hello function, which returns a string, attached to the struct. So as long as any type is has those functions attached, it will pass on as an interface. It may be confusing at first, and I mean it definitely is, because you cannot know, but just by looking at the type declaration, you don't know all, what it implements. So you'd have to use some reflective functions to check what interfaces does a struct implement. Next feature with Go are pointers. Go has pointers, but like all other features that we mentioned already, it kind of has and it kind of hasn't. It has pointers because all pointers have a definitive type, like they're a separate type from everything else in your system, but it doesn't support pointers in a way that you cannot manipulate its value. So you cannot manually change the memory allocation on that pointer, which is kind of okay for a lot of people, because you cannot really screw it up by messing up with your pointers. But it's beneficial because you always know if you're dealing with values or references. Pointer, like I said, is a type, and it's denoted with the asterisk symbol. So if we take a look at these two declarations for variable A and B, variable A will have a type person, while variable B will be of type pointer, which points to some value that is a type of person. Might sound weird right now, but it gets more clear once you start using it a little bit. And like I said, we always know if we're dealing with pointers or values, because when you're like declaring a function which has some arguments, when you declare argument, you always have to declare is it only a value or is it a pointer. And if it's a pointer, you have the asterisk operator, which will get you a value from that pointer if you don't want to mess with a pointer. So like you wanna do something with a variable and you want those changes to stay in the scope of that function, you can always only extract the value from the pointer and deal with that. On the other hand, if you have a value and you wanna get its pointer, you can do that with the ampersand operator and fetch the pointer if you wanna like mess with the value outside of the scope. We can see this in this example where we are declaring A as a string, P will be a pointer to that string, and we extract the pointer with the ampersand symbol. And after that, we are going to extract the value from the pointer in the variable V. See, the first is a pointer, which is just the memory allocation of our string, and when we extract the value, it's the same as A. Go also features multiple return values. This is one of the features which is kind of borrowed from the dynamic kind of languages. Is that like every function can return multiple number of values. So it's not only returning one value; it can return a lot of those. It's it's commonly used for returning errors. When we take a look at this example, this function will return, it's declared that it returns three values, returns integer, it returns string, and it returns error. And we're returning 7 hello and a new error. When we are invoking that function, we have to name three variables which will be assigned the values that some function will return. In this case, that is a, b, and error variable. But if you don't need all the values that the function is returning, you can always omit the values returned from a function by using the underscore operator. So in second example, we will only assign hello string to variable c. But why omitting variables? If I could just always assign to a and b an error and just not use that variable anywhere else, because Go compiler will not let you have an unused variable in your code. It's also one of the opinionated things about Go. It will, like that, also not allow you to have an unused import. When we run this, we'll see exactly what we're expecting. So we mentioned errors, and errors are a hot topic regarding Go, and because Go does not really support exceptions, and people are very keen on using exceptions as a means of error handling. Go doesn't really like that, and it's not really a Go way of doing things. So if you have a function which can have an error in itself, which can result in an error, you always need to return an error as another value from that function, instead of throwing an exception and messing with your program flow. And especially because if an error happens along the way, that doesn't mean that the function will not return a usable value. So it's not exclusive. Either everything is successful and everything is fine, or I'm returning error and I'm returning nothing else but the error. Because in Go you can do both things. It's very beneficial because errors are common. Errors are expected. Errors are something that happens all the time. And exceptions are exactly that, exceptional state of things. For example, when you query a database and there are no rows for what you're querying, that's not an exception. That's a common behavior. That's just an error. It's not exception. Nothing exceptional about it. But if you really like the exceptions, there are panic and recover functions which can be used when your program is not really behaving correctly. For example, it fails to connect to the database. That's an exception. But we'll not go into any more details about errors, except when we talk later on about the criticisms on that. The meaty feature of Go are Go routines and channels. We'll cover those now. Go routines is a way of Go to provide asynchronous execution of code. Something like threads, but extremely lightweight, because you're not actually running the detached code in a separate thread. You are actually just running it as a detached function in the Go runtime. Go runtime will determine in which thread it will be run. So you're not really dealing with any system threads. Go runtime will handle all of that. We can look at this example now. We have a save function which will print out a string 5 times over some period of time. And then we have 3 invocations of it. First is go say Belgrade. Then we have go and some anonymous function declaration, and just a regular invocation of function say. Go is the keyword you use when you want your code to run asynchronously and run in background. So when we run this example, we can see that hello's froms and Belgrades are not synced up in absolutely any way. So that's something like that. This is multi-threading for you in Go. And how do those Go routines communicate to each other? Like they need a system, because if it's running background and it returns some value, you're not able to get it. So enter channels. Channels are a pipe system which can connect the concurrently run Go routines. Basically like a pipe between two functions, and you put a value to one end, it comes out of the other end, and the other Go routine has an access to that value. Let's take a look at the example. We are making a channel here with the statement make channel. We declare which type will the channel accept. So we know that this channel will only accept strings, and we run a function which will, after 3 seconds, send the hello string to the channel. And in our main Go routine, we will wait for the message from the channel. We're waiting 3 seconds, and there it is. You probably noticed that when we are reading from the channel, the Go routine blocked, meaning it will wait for the message to be available before it will continue the execution, before it prints out the result. So when we are sending or receiving on, when we are receiving on an empty channel, the call will block, and when we're sending on a full channel, the call will also block. That's why, if you want some more maneuverability in your code, channels can be buffered. So just increase the capacity of messages it can store, it can put through itself. So if, for example, our channel has a 5-item buffer, we can send 5 messages to a channel before it starts to block, and also we can read all the 5 messages before the channel is empty and before the call starts to block. But one thing to feed on your mind is, like, if channel is just another type, just another value, like everything else in Go. And as that, you can send channel through another channel, which can give you limitless possibilities how you want to schedule your asynchronous code to work. And it can act as message queues, as a thread pool scheduling mechanism, like whatever you want. What is now, when we've covered the most of prominent Go's features, what it's good for and what is the common criticism? Let's see first who uses Go. This image can speak instead of me for a few minutes, but we can only say that there is a huge adoption of Go by leading IT companies. Not only Google, but both Twitter and Facebook and Apple, and everybody's using it. So you cannot say that Google is just pushing it by marketing. It's just that all these companies have saw the value in it, and they saw that what it's good for, that it's very, very developer friendly, very productive, even though it's not perfect. It's not as good as C, maybe it's not good as C++, maybe it's not good as Java in some cases, but it's like a very well all-rounded general purpose language. For example, Twitter uses it for managing their millions and millions of their web sessions. SoundCloud, Netflix, and Twitch use it for their streaming services. Uber, Stack Overflow guys use it for maintaining and monitoring their infrastructure network. SpaceX, Elon Musk and everybody are using it for their telemetry systems. Apple And we know only about those because all these companies have been putting up blog posts how Go helped them, and they've been open sourcing parts of their projects written in Go. So that's the only way we know that they're using it. But like Apple and Facebook didn't really open source anything, didn't write any blogs, but they have been posting some job advertisements requiring Go knowledge. So it's a pretty good guess that they're using Go too for some stuff. And of course, last but not least, Docker, the most hot technology in the field right now, is written in Go. But if Go is so good and everybody's using it, why has been so much criticism about it? You probably read there have been like a lot of topics on Hacker News, on Reddit, people writing blog posts and everything, that Go is not good. And the first and hot criticism is Go's type system and lack of generics. It's a big one, and I personally really miss generics in Go from time to time. But I've grown to like the Go's type system because it does one really good thing for me, maybe for others as well, but it doesn't allow me to over-engineer stuff. So with Go's type system, I cannot go make this crazy generic code, which is like an absurd type systems, which sometimes we must admit we tend to do that, and we like to make our code like the most generic thing, the most elegant stuff, like we like to call it art. But Go is there to punch me in the face, like keep it simple, don't be stupid. And I cannot over-engineer stuff with Go's type system. Really, I really cannot. Sometimes I may want, but it just says no, you cannot do that. Same with function composition and with functional features, because I'm a big fan of functional languages, and I use functions as parameters, as return values as much as I can, but Go is there to slap me like, no, this is not efficient here, you cannot do that. That's why I like Go's type system and the lack of generics. But a lot of people are very kind of grown to them, and they've been using it for so long, and it's a big feature to miss out. And if you're kind of feeling bummed out because Go doesn't have generics, good news is that they did not say definitive no to it. They say it may be implemented sometime in the future, but right now we don't want to ruin our current runtime, our compile times, by including generics. So we're not going to include it right now because it's not essential to what Go wants to achieve. But at one point in the future, why not? Error handling and exceptions is the second thing that people have been complaining most about. But it's a bit strange because, like I explained already, errors are not exceptions. Errors are common, errors are accepted, and exceptions are just exceptional. It's not something that I want my code to do. This is like the thing which I never want my code to do. And I want my code to return errors when errors happen. And I think I don't want exceptions to stop my program flow and bubble up and not execute anything that happens after the exception is thrown, and wait for something to maybe catch it when it bubbles up there. It just messes with the flow, and it doesn't execute the function in its entirety. And I think that the criticism there comes mostly from people's habits. Like, people are feeling the exceptions are crutches for them. They've been doing it for so long, and they don't want to kind of switch boat. But maybe they should try, because Go's error handling is okay. And yeah, also with error handling, people are saying like the code becomes too verbose. Like, you always check if there is an error. Every function you call, it may return error, and you check if error is nil, then do this. And if error is nil, you do that. And you're always error checking. But is that really worse than having to declare like try statement and then catching the exception? And if there are multiple exceptions, you have to do the multi-catch. And I don't think it's more complicated or more verbose, because just checking if there is an error or not is the simplest you can get. Complaining that Go is too simple, it's a bit contradictory, but yeah, Go is so simple that it kind of forces you to use its very simple code constructs, and in a way you will have to repeat them over time. You will always have to, like I said, you will always have to go with if error is nil, or there are, for example, no one-liners for if then else, so you always have to go full if statement and do something like that. So basically, there is not a lot of syntactic sugar, not some helper syntax for dealing with arrays or maps, and more syntactic sugar would be welcome. But I don't think that Go is just too simple. It's simple, and it's allowing you to do simple things. If you don't want to do simple things, if you want to do overly complex things, don't use Go. It's simple as that. Bad dependency management. Go is often praised for having the built-in dependency management tool, which is the Go Get, which allows you to fetch automatically all the dependencies that you need, that you want. While in other languages there are always some external tools, external repositories, or everything. But it has this big flaw that it doesn't have versioning, which kinda sucks big time. And they're looking to fix it in one of the next releases. And last is the weak ecosystem. Not something you can really pin on the language itself, but more for the maturity of its community. But a lot of developers I've been talking to personally have been saying that, like, I don't want to go with Go. I don't want to try it because it doesn't have full IDE support. Other languages have more libraries. There are like not enough Stack Overflow questions, answers. I mean, it's unlikely for me to find a solution for the problems I'm facing. It may be so, but that's only because Go is very young still, like barely over 6 years old. So that will come in time. And like I mentioned, yeah, IDE support, Go kinda throws you back to the 70s in a way. It kind of pulls you out of the IDE and puts you back in the terminal. So Go wants you to use the terminal more and to use the Go tool and to use its provided tools for code analyzing and to run it from the console. And just don't be lazy. Don't stay in IDE. Don't wait for someone else to write the plugin for IDE. Go has great tools for managing your code from the command line, and it's very accessible. So if you have a favorite editor, you can write the plugin for Go very easily. And not a lot of people like that. Just this, they like the comfort they feel while they're in IDE, but some people are rebels, some are not. Okay, so now that we know so much about Go, we can maybe deduct where it really excels. So the truth is, the Go is a general purpose language. It's good fit for anything. So you can do really whatever you want to do, you can do it with Go. It may not be the best fit for everything, but it's a good fit for anything. And we saw that by with all the big companies that are using it. For what purposes are they using it? That just the uses are everywhere. So you cannot say that, well, Go is good only for this and for that and nothing else. But if we can see what the Go is exceptionally good at, I would say rapid prototyping. That's why Go has been adopted by so many startups. lately because it's simple. They don't have to deal with the tech stuff. They can deal with the product. They've been able to build the stuff they want very, very fast. I mean, this Ruby was the king of rapid prototyping, and Go is kind of stealing its thunder for the last couple of years. Still not there, but getting there. Yeah, tooling and command line applications. It's so easy to write a simple command line tool in Go that sometimes myself I've been using it instead of Bash for just dealing with some, for example, build processes or moving stuff around or creating like a mock-up development server or whatever. It's very, very easy to write simple tools and simple command line applications. Go goes in favor of microservices infrastructure, or at least mini services where you want to benefit from having the cluster of as much more single decoupled independently scaled applications. So you don't want to go like big huge monolith application with Go. You want to build small things and then run them each independently, because Go has really good communication systems, and it has a very small footprint. Like when you build a Go binary for example, I don't know, 500 lines of code, it's gonna be, with all the dependencies, maybe like 5 or 6 megabytes or something, and that's really small for today's standards. Because imagine running that example in a VM backed language, and you have to run the whole VM infrastructure just behind the small portion of code that it's going to run. Take Java, for example, take JVM. If you want to run 500 lines of code as a single application, it's going to be 500 megabytes. So Go is in favor of using simple, small applications and having a lot of them. Go is great for intensive I/O stuff, for networking, for file systems, for system calls, you name it. If you have a big throughput of data that needs to be processed from the network or from the file system, Go is a great fit because it's a systems language, basically. It's natively compiled. It doesn't have a big footprint. It will do all this stuff very, very fast. And this is why, this is my personal opinion, that Go is just for that. It's great for building databases. And there have been a lot of databases emerging last couple of years built in Go. And I think even CouchDB and Mongo have been starting to rewrite some of their core components in Go. So if you want to build a database, try with Go. I think it would turn out great. A lot of examples where it happened. But where it falls short, truth is, as a general purpose language, nowhere in particular. Because, like I said already, Go is a good fit for almost anything. But that doesn't mean that Go is the best choice for every job. Already mentioned, you don't want to build huge monolithic applications in Go. Because Go, there are two reasons for that. Because Go, first, is still a compiled language. If your code base grows exponentially, the compile times are going to increase as well. So even if it does compile fast, for a huge code bases, it's still going to compile slower than what you would expect and than what you would want. The second reason is huge monolithic applications tend to have huge big type hierarchy systems, and you cannot create those efficiently in Go. So if you want to build a monolith, don't go with Go. Go with something else. Go with Java or C# maybe. Next example where I think the Go is not a good fit is where tight memory management is essential. Like every other language which has a garbage collector, Go will have some garbage collection overhead, and it will not be able to um, handle the memory the way you could do it manually in some cases. So, like if you want to build a physics engine, don't use Go. Use C++ and everything that goes with it, like all the manual memory management. One dynamic environment sounds very vague, but I'll try to explain it because of Go's type system. Very dynamic environments may not be a good fit because you will have a lot of dynamic data going around, and you would want to have types defined for that data that goes around, and for really dynamic data, Go will not be a good fit because of lack of generics, and because Go is not a dynamic language. So if you have, I mean, you can write typeless code in Go, but it will be cumbersome, it will not be efficient, it will be hard to maintain. So in those cases, just use a dynamic language, something like JavaScript or Python or whatever else you like dynamic, without strong type systems. What's the future of Go? The really good thing about Go is that it's an open source project, but it doesn't accept a lot from community in terms of like pull requests or something. But it has a dedicated team now, even though it started as a homebrew project from 3 other developers. Now Go has a dedicated team which develops features and maintains the code. Community contribution is very welcome, and for example, like you never know what's going to be in the next Go release. They don't have a really specified roadmap for what features are they going to include, or what are they going to change, because it changes so fast with all the community input, and those release cycles are very short. We have major version each year. So now I think by the end of the month 1.6 will be released. This is the 7th major version from 2009. And like I said, no strongly defined roadmap. They take so much community input. So we don't know what's going to be in Go 1.7. Not a clue. But in 1.6 they will be improving garbage collector. They will be improving compile times. They will try to elevate some of the dependency manager issues that they've been having. There will be support for HTTP2 protocol, and that's pretty much all we know. We will know more when there are release notes and where the next version is actually released. One thing that we know that Go will focus on the future is the mobile support. That means like compilation for mobile devices and for Apple's processors, for ARM processors. There have been there was big support for ARM processors in Go 1.5, where you could build Go programs and applications for Android. There is also a development kit. You can build some Android stuff for it. I mean, not really a full-blown application, but you can build libraries in Go, which then you can use in your standard Android Java code. And I think that 1.6 will have the same support for Apple as it had for Android in 1.5. I also want to mention the Gopher Gala. This is the yearly event that happens as of last year. That is a Go hackathon, which is just a hackathon there to kind of promote the image of Go, to pull the new developers in, to make them try new stuff. So it's actually next weekend, and it's totally distributed. You don't have to be somewhere specific. You can work from your home. You don't have to have a team. You can work solo or in teams of 2, 3, 4. There is also Go for Gala Slack where you can match up with some other people who are also doing solo. So, and the only requirement for the hackathon is that whatever you're doing, it needs to be done in Go. You can do whatever you want, and that's basically the only requirement there is, and also to be completed in 48 hours. So if it's very beginner friendly, even if you haven't done Go at all. Like I said, Go is very easy to get into, and it's very easy to build small stuff right away. I encourage you to team up, maybe later after this or on our Slack, GolangBelgrade. Team up with some people and try to pull something off. I was participating last year and I had a blast. I paired up with some random Brazilian dude. We were coding like 40 hours straight. We reached top 20 in the end, but like the amount of stuff I learned in those 2 days was unparalleled because it's just such a motivator for you to get into language more. So the conclusion is, Bjarni Straudstrup, the creator of C++, said, there are only two kinds of languages, the ones people complain about and the ones nobody uses. Well, he would know, he created C++. And Go also, like C++, fits right into that description because it has seen huge adoption over its small lifespan. I mean, compared to other new languages like Rust, for example, Go has tremendous adoption. And of course, people will complain about it, but in the end, it has its uses, and it's very useful to a lot of people, to a lot of companies, and I think that Go really strike the balance between productivity, efficiency, and compilation times as well. So people are loving it, and it may not be perfect. It's not a universal solution to all problems. Really, it's not perfect. And me personally, like I said, I don't want to sell you Go. You always need to choose right tools for the right job. There is no one language that will fix all your problems. But Go may fix some better than the other languages. It's very comfortable, very easy to use, and I really encourage you to try it. And I hope and with this talk, contributed a little bit to that. Have fun using Go, and thank you for attending and thank you for being here.